So let's continue past paper session, and this time I've selected paper 6, that is alternative to practical. You know, it's May, June 2025 and variant is 61. This time I've selected variant 61. The total time for this paper is 1 hour. You have to answer all the questions on the question paper. You can use black or dark blue pen. Do not use an erasable pen or correction fluid. Do not write on any barcodes. You may use a calculator. You should show all your working and use appropriate units. The total mark for this paper is 40. So the important thing is that notes for use in qualitative analysis are provided in the question paper like this. That includes it includes tests for anions, cations, gases, and flame test. So let's start the paper. Here's question number 1. A student prepares some crystals of pure potassium sulfate by reacting aqueous potassium carbonate with dilute sulfuric acid. The equation for the reaction is shown. K2CO3 aqueous plus H2SO4 aqueous gives K2SO4 aqueous plus H2O liquid plus CO2G. The student places 25 centimeter cube of aqueous potassium carbonate in a conical flask, adds a few drops of a suitable indicator to the conical flask, uses a burette to add dilute sulfuric acid to the conical flask until the end point is reached and the indicator changes color. Table 1.1 shows the burette readings the student obtains. We have final burette reading, initial burette reading, and they left blank for volume of dilute sulfuric acid added. A. Complete table 1.1 by calculating the volume of dilute sulfuric acid added to the conical flask. So you simply have to subtract 4.2 from 18.8. So we will get 14.6. B. State which solution aqueous potassium carbonate or dilute sulfuric acid is the least concentrated. Give a reason for your answer. So if you look at the reading, we have 14.6 centimeter cube of sulfuric acid used here. And if you compare this volume with the volume of aqueous potassium carbonate, it's 25. The volume for aqueous potassium carbonate is higher than this one. So potassium carbonate will be the least concentrated in this because less volume of sulfuric acid used. So you can write potassium carbonate, and for the reason what you're going to write, you write less volume of H2SO4 used, less volume of sulfuric acid used, or what else you can write? You can even write larger volume of potassium carbonate used or larger volume of potassium carbonate used. C. Name a piece of apparatus suitable for measuring the 25 centimeter cube of aqueous potassium carbonate. We usually use pipette or burette. So you can write burette or pipette. You can use these for transferring this volume of aqueous potassium carbonate. D. Name a suitable indicator and give the color change of this indicator at the end point. The indicator they gave in the marking scheme is methyl orange. And this is something which you have to learn. You are adding acid to the potassium carbonate. So potassium carbonate will be the base here. So initially the color will be yellow and it will change to orange. E. As the student added the dilute sulfuric acid to the aqueous potassium carbonate, they looked for a color change. State what the student should do as they add the dilute sulfuric acid to the aqueous potassium carbonate in the conical flask. Do not include observations in your answer. Definitely, the student need to mix or fill the contents of the flask. Mix or fill the contents of the flask during addition. Part F. Describe what the student should do to obtain crystals of pure potassium sulfate. So first of all, the student need to mix 25 centimeter cube potassium carbonate and 14.6 centimeter cube sulfuric acid without indicator this time. It's very important because then student need to remove that indicator in order to get the crystals of potassium sulfate. After this, student will evaporate or warm until crystallization or saturation point. Then student will cool or crystallize. So you write mix together. (25 centimeter cube potassium carbonate and 14.6 centimeter cube of sulfuric acid without indicator. Remember, the student need to mix this without indicator. Next, evaporate or warm. Evaporate or warm until crystallization. Then cool or crystallize. Cool or crystallize in order to get the crystals of potassium sulfate.
Welcome to Chain of Qualified Tutors. Unlock your academic potential with expert tutoring, from secondary school to graduation level. Master math, science, English, and more with personalized one-on-one guidance. Call or WhatsApp for a free demo session. We offer on-site and online tuition.
Question number 2. A student investigates how the rate of reaction of magnesium ribbon with dilute acid changes as the concentration of the acid is changed. The student uses 5 solutions of the same acid, A, B, C, D, and E. Each solution has a different concentration. The acid is in excess in all experiments. The student does 5 experiments. Experiment 1. Use a 50 centimeter cube measuring cylinder to pour 30 centimeter cube of acid A into a 100 centimeter cube conical flask. Add a coil of magnesium ribbon to the acid in the conical flask and immediately start a stopwatch. Continually swirl the mixture in the conical flask until the magnesium ribbon disappears completely. Immediately stop the stopwatch and record the time in seconds to the nearest second. Empty and rinse the conical flask with distilled water. Experiment 2, repeat experiment 1 using 30 centimeter cube of acid B instead of acid A. In experiment 3, the student repeat the same procedure. This time, acid C is used. In experiment 4, acid D is used. And experiment 5, acid E is used. A. Use the stopwatch diagrams to complete table 2.1. Now, experiment A, which is done with acid A have concentration of 2 mole per dm cube. The stopwatch diagram is given. So the time, if you look at this carefully, only seconds are there. We don't have any minutes. And if you look at this carefully, you have 20 seconds here. So you write 20 seconds. For experiment 2, the acid B with concentration 1.5 mole per dm cube. Again, you don't have minutes. We have this time, we have 25 seconds. So I will write 25 seconds. For experiment 3 with acid C, concentration of 1 mole per dm cube, we have 42 seconds. If you look at this, we are having 42 seconds here. Experiment 4 with acid D of concentration 0.8 mole per dm cube, we are having 56 seconds. For experiment 5 with acid E with the concentration of 0.5 mole per dm cube, we have 1 minute and 35 seconds. So you're going to add this. 1 minute means 60 seconds, 60 plus 35. 60 plus 35, and you will get 95 seconds for this. B, write a suitable scale on the y-axis and plot the results from experiments 1 to 5. On figure 2.1, draw a line of best fit. Now, on x-axis, there is concentration of acid, and on y-axis, we need time for magnesium to disappear in second. So I'm taking 10 seconds here, 20, 30, 40, 50, 60, 70, 80, 90, and the top one will be 100. So we have the data here. You use this data and draw the line of best fit. What you will get? You will get this. This will be the graph you will obtain after placing the values for, I'm going to write for each experiment. The top one is of experiment 5, this one of experiment 5. This one experiment 4. This one experiment 3. We have experiment 2, and the last one experiment 1. Because in experiment 1 you have 2 mole per dm cube acid, and the time for the magnesium disappear, it's 20 seconds. Now what they are asking, from your graph, in figure 2.1, deduce the time for the magnesium to disappear when the concentration of the acid is 1.3 mole per dm cube. Look at this carefully. 1.3. Here's 1.3. The time, it will be 32 or 33. 32 or 33. It's 33. If you look at this carefully, it will be 33 seconds. For D, the mean rate of reaction is calculated using the equation shown. Mean rate of reaction is equal to length of magnesium ribbon in centimeter divided by time for magnesium to disappear in second. The length of each coil of magnesium ribbon used in all 5 experiments was 5 centimeters. Calculate the mean rate of reaction experiment 1. Give units for the rate you have calculated. Now experiment 1, we have 5 centimeter cube. That will be the length, 5, and divided by the time. The time for this is 20. 5 divided by 20. So what you will get? 5 divided by 20, and we get 0.25. 0.25. What about the unit? We will have centimeter per second. Centimeter per second, or cm dot second minus 1. To deduce in which experiment 1, 2, 3, 4, or 5 the mean rate of reaction is the slowest. Definitely, if you look at this graph, it's experiment 5. You see, 95 seconds is taken for magnesium to disappear. So it's experiment 5. Straight away you will write experiment 5. E. Explain why repeating each experiment is an important. This will help us in to verify or compare results. To verify or compare results. F. The student does another experiment to find the temperature change when magnesium reacts with acid A. Use a measuring cylinder to pour 30 centimeter cube of acid A into the 100 centimeter cube conical flask. Measure the initial temperature of the acid in the conical flask. Add a coil of magnesium ribbon to the acid in the conical flask. Continually fill the conical flask until the magnesium ribbon disappears completely. Measure the final temperature of the acid in the conical flask. 1. Use the thermometer diagrams to complete table 2.2. So, the initial temperature, if we look at this, it will be 24 degrees centigrade. What about final temperature? It will be 45, 46, 46.5. So I'm going to write 46.5 and temperature change must be 46.5 minus 24. 46.5 minus 24. 22.5. Number 2, explain why controlling the temperature of the acid so that it remains constant is an improvement. Definitely the rate of reaction changes with change in temperature. That's why it's very important to control the temperature. Rate of reaction changes with change in temperature. Number 3, explain why using a polystyrene cup instead of the 100 centimeter cube conical flask does not control the temperature of the acid. Polystyrene, it's an insulator and therefore prevents heat escaping. You're going to write polystyrene is an insulator and therefore prevent heat escaping. Number 4, describe how the temperature of the acid can be controlled and kept constant. So the best way to do this by using water bath. And this can be controlled in a convenient way. Use water bath. Question number 3. A student tests two solids, solid F and solid G. Test on solid F. Solid F is calcium carbonate. Now they gave us the name of the compound, calcium carbonate A. If they gave us the compound, then what you have to do, just quickly look at this qualitative analysis list and recall the test for the calcium ion and carbonate ion. Then you will be able to answer these questions very easily. The student adds about 15 centimeter cube of dilute hydrochloric acid to the sample of solid F in a boiling tube and test any gas produced. This is of 2 marks. So definitely the carbonate ion is there. It will react with the hydrochloric acid, producing effervescence, bubbling. So you write fizzing, bubbling, or effervescence. Now they are also saying test any gas produced. So gas turns lime water milky. You look at the list. Test for carbon dioxide. Test for carbon dioxide gas. It's carbonate ion. Test for carbon dioxide gas, and it's given here. If you look at the list for the gas, it's carbon dioxide, it turns lime water milky. So you write gas turns lime water milky. B. The student filters the product from A to obtain solution H as a filtrate. The student divides solution H into three approximately equal portions in three test tubes. Number one. To the first portion of solution H, the student adds about 1 centimeter depth of nitric acid followed by a few drops of aqueous barium nitrate. Observations. Now, barium nitrate is used to test what? If you look at the list of the anions, you have sulfate ion here. This one is used to test the presence of the sulfate ion. So we know it's calcium carbonate. So for observation, what you will write? You will write no change. As sulfate ion is not there, so it won't give any white precipitate or any reaction. 2. To the second portion of solution H, the student adds aqueous sodium hydroxide dropwise and then in excess. Observations when added dropwise, observations in excess. This must be for Ca plus 2 ion. Look at the list here. Cations list. Here's the cations list. Where is calcium? Here's calcium. So with aqueous sodium hydroxide, we have white PVD, which is insoluble in excess. So first you write white precipitate. White precipitate. Then in excess, what's happening? Insoluble. Insoluble. In excess, it's insoluble. Part 3. To the third portion of solution H, the student adds about 1 centimeter depth of dilute nitric acid followed by a few drops of silver nitrate. Observations. This must be for chloride ion. You look at the list of the anions. Here are halide ions, and this one is a chloride ion, aqueous silver nitrate. And for the chloride ion, if you look at this, what we are getting here? If you react calcium carbonate with hydrochloric acid plus hydrochloric acid, we have already produced calcium chloride here. So it must be having chloride ion here. The chloride ion is here. So observation, it must be white precipitate. So you write white precipitate. Move to next part. Test on solid G. Shows a test and student's observation for solid G. Do a flame test on solid G. Lilac colored flame. Test 2. Dissolve the remaining solid G in water to form solution G. Divide solution G into 3 portions. To the first portion of solution G, add about 1 centimeter cube of aqueous chlorine. Orange solution forms. Test 3. To the second portion of solution G, add about 1 centimeter cube of aqueous sodium hydroxide, remains colorless. Test 4. To the third portion of solution G, add about 1 centimeter cube of dilute nitric acid followed by a few drops of aqueous silver nitrate. Precipitate forms. Looking at these positive results, we have positive here. That's a change. We are also seeing change here in case of this test. That's test 2, test 1, test 2, as well as the test 4. This does not indicate anything. So what they are asking, see, identify solid G. So solid G flame test, it's giving lilac color now. So if you look at the list, where's the flame test? Here's the flame test. So lilac, here's lilac, it must be having potassium ion. So one thing is sure, it's having potassium or K plus. You can write either K plus or potassium. What about the other details? If you look at the test 2, they are saying chlorine is passed, aqueous chlorine, and it's turning orange solution. So chlorine, if it reacts salt of bromine or iodine, it will displace it. And this will be indicated by the change in color. You know, these are the halogens. Group 7, chlorine, bromine, iodine. So in this case, chlorine is displacing this bromine from salt solution G here. That's why this orange solution is formed due to Br2 formation. So this indicates that it must be having Br minus. Let's see another test. There is another test given with dilute nitric acid followed by aqueous silver nitrate, and this is for the halogens, halide ions, I mean. Here's a test. Here's a test. If you look at the details, green precipitate, it's for the bromide ion. So it must be bromide. So what you're going to write? Bromide or Br minus. So this will be the final answer for this one. Number 4. Solid sodium hydrogen carbonate NaHCO3 reacts with dilute hydrochloric acid and with dilute ethanoic acid. Here is the reaction equation. Sodium hydrogen carbonate reacting with hydrochloric acid to produce sodium chloride plus carbon dioxide plus water. Other reaction, sodium hydrogen carbonate reacting with ethanoic acid to produce sodium ethanoate and carbon dioxide and water. These two reactions are endothermic. What are endothermic reactions? Delta H will be positive in each case. So both of these reactions absorbs energy from the surrounding. Plan an investigation to find which of the two reactions is the most endothermic. Your plan must include how you can use the results to find which reaction is the most endothermic. You are provided with solid sodium hydrogen carbonate, dilute hydrochloric acid, dilute ethanoic acid, and common laboratory apparatus. The total mark for this question is 6. And they are not asking you to draw any diagram, label diagram of apparatus. So you have to write the name of the apparatus in order to gain at least 1 marks. So you can write any 6 from these. So how I'm going to start? I have to take the known mass of sodium hydrogen carbonate in each case. So you'll write take known mass of sodium hydrogen carbonate. What else you can write? Again, you have to take the known volume of dilute hydrochloric acid and dilute ethanoic acid. So take known volume of dilute hydrochloric acid and dilute ethanoic acid. You have to mention for both in this one statement. Then you have to write the name of the container in which you are taking these. Name the container used for this reaction. Name the container used for the reaction and measuring the volume of acid and measuring the volume of acid. So you are taking known volume. So definitely you need pipette or burette. Burette will be the best one here. Burette or pipette for this purpose. For the container used for the reaction, we can do this in a beaker. So you can write beaker for the container for the reaction. What else you can write? Definitely you have to measure the initial temperature before the reaction, beginning of the reaction. Measure the temperature of the acids. Measure the Temperature of the acids. Acids, you know, it's hydrochloric acid and ethanoic acid before the reaction or mixing. What else you can write? Mix the reactants and stir. Mix the reactants and stir. Then what you are having? Then you have to note down or measure the temperature of mixture. Note down or measure the temperature of mixture. Temperature of mixture. The last point, the biggest temperature decrease means most endothermic. Biggest temperature change, temperature decrease means most endothermic. So how many points are there for this one? Let's see the points. We have point 1, 2, 3, 4. Sorry, this is not 4th point. This one is a 4th point. 5, 6, 7. Write down any 6 of these in order to gain full 6 marks. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.